All right, we're going to evaluate a definite integral, in particular an area under a curve. So I'm going to be looking at something that looks like this. The integral from 0 to 30, these are in degrees, but they could also be in radians, but we'll do it in degrees for now, of 2 sine 3x dx. Okay, one of the first properties we looked at was that if you have a coefficient within your integrand, then you can actually take that out of there, get it out of the way just to kind of simplify the integrand a little bit for yourself. So that can come outside. We can still make sure we're doing the integral from 0 to 30 degrees. And now that I've moved this 2 out, the integrand becomes sine 3x dx. Okay, so it's almost like the formula that we have, which looks like this, that the integral of sine u du is equal to negative cos u. That's an indefinite one with plus c. I'm going to write that there because that's what the formula looks like, but we don't need to worry about plus c because we are doing a definite integral, which will be subbing in these upper and lower limits. And that's the difference between an indefinite and a definite integral. All right, so something to note about this. If this was said u, then I would have sine u du. That's like the formula. So we're going to do this part here where we say, well, let's let u equal 3x. This part's u. And that represents that u right there. The rest, something else we need to know is du. So from this, we have to evaluate du. So du then is equal to 3 dx. And notice, we don't have a 3 in here. We just have a 1 dx other than the sine u. So we have 1 dx. We don't need 3 dx. That's 3 times too much. So we need to solve this for just the dx, not the 3, which means divide by 3 or multiply all by 1/3. So 1/3 du is equal to dx. Now we have actually figured out the value that this integrand needs to be multiplied by to actually get the correct answer. I'm going to go back to black because we're going to continue down here now. So this is equal to, I have the 2. This becomes also part of the coefficient, and it becomes the integral from 0 to 30 of sine u du. Now why does that fit? Let's have a look at that. If u is 3x, so far it says sine 3x, sine 3x in a way, dx is equal to 1/3 du. So there's my 1/3 and there's my du. So those two together make up dx. So that's why these are equal. And we have a formula for this, which is that is equal to minus cos u. So let's go back and sub this in, or continue down the next line. 2 times 1/3 is 2/3. We know now that this is equal to minus cos u. And so instead of writing u, I'm going to sub back in the 3x. And this has to be evaluated from 0 degrees to 30 degrees. So that's equal to 2/3. When you evaluate from 0 degrees to 30 degrees, what you want to do is sub in the upper limit first for your x value, and then subtract the value with the lower limit subbed in. So let's write that out. Minus cos 3 times 30, subtract, because I'm evaluating the difference between these, minus cos 3 times 0. I think I got an extra bracket. Don't worry about that. All right, so now we need some values. This is when you would either use your memory, grab your calculator. So that is 2/3. The cosine of 90. Cosine of 90 is equal to 0. So putting a negative in front of it doesn't really matter. That's a value of 0 right there. Minus, and then this minus, the cosine of 0. Cosine of 0 is equal to 1. So this is 2/3 times positive 1, which is 2/3. Or as a decimal, 0.6 repeated. All right, thank you.